This video is for 0232-1332 as we cover sections 7.3 and 7.4. 7.3 is simple interest and 7.4 is compound interest, so two very similar topics. I will be sending you in an email this week a copy of this formula, financial formula page. So if you print this out, you can use it on the next test. As long as you don't add any notes to it or anything, just leave it as is and just print it out. You will have to print it out if you're going to use it during a test, because it won't let you open it after you start your test in the Alex lockdown browser. So simple interest, there's two formulas used. One is if you just care about how much interest is either owed or how much you have to pay back or how much you receive as an investment. So it turns out in these financial formulas, it doesn't matter if you're the one making the money by investing or if you're the one having to pay money back if you're a borrower. The answer is the same either way. It's just whatever point of view you want to take. And in simple interest, there's two main formulas. One is this, where all you care about is how much interest is involved. And I is the abbreviation for interest. P is present value or principal. So they usually call it the principal amount of money that's borrowed or invested, but it's a good way of thinking about it is present value, because it's how much money is going on right now in the present time. R is the interest rate, and they almost always quote the problem in a percentage, but then you need to work in a decimal while you're calculating. So that's why in that first section of this chapter, we spent a lot of time changing things from percents to decimals and back and forth. And then T is time, T is time, but it has to be in years for the formula to work. So if they don't give you years, we have to adjust for that. So number one says find the missing value, round to the nearest cent. Another thing too that's important, and I can't remember if I mentioned this in the first video or not, because I also have a class in person at HCC that's doing the same stuff. If the problem's about money, which generally this entire chapter is, you always have to round the final answer to the dollar or the cent, and they'll always tell you which one to do. But what that really means is you'll either have no decimals or two decimals in every answer. We never put one decimal, we never put 3, 4, 5, 6, 7. It's how money works. Money's always either dollar or cents. Notice the time here is years. So the principal or present value, somebody's borrowing or investing $19,000. They're getting a 7% interest rate, and it's for 5 years. That's literally what the formula means. Interest is principal times rate times time. You basically just need a calculator that has an exponent button on it. So right here, I have a button that says x raised to the y. We'll need that, not right now, but later that's going to come up, and even later in this video right here. So if I take the principal amount of money, the money that's being borrowed or invested right now in the present time, times the interest rate, but change it to a decimal 0.07. You got to move the decimal over twice. 0.07. So maybe you have to do that separately first, like we did in section 7.1. It's 7% is very commonly mixed up with 70% by students, and they don't know which one's 0.7 or which one's 0.07, but 7% is 0.07. And then the time is in years, so I just multiply by the time. So if you borrow $19,000 for 5 years at 7%, you'll owe $6,650 on top of the money that you borrowed. Or if you're the investor, you'll get your money back, and you'll get this. This is your profit for loaning the money to somebody. Simple interest was how it was originally done over 100 years ago when the financial world was taking off, because back then nobody had calculators. There was no computers or calculators back then, and all the work was done either like with their fingers in the sand if they were outside, or they would do it on paper. And simple interest is just easier to work with. Once calculators and computers came around in the last 60, 70 years, then it's kind of switched to the compound interest you're going to see next, because then calculations weren't so difficult to do. Same kind of problem, just different numbers. I'm taking $23,000 and change 8% to 0.08, and then times the 2 years. So this one's got a slightly higher rate, but it's less time, so that's why you make less money if you're the investor. $3,680. And these are coming out exactly, so even though it says round to the cent, if you get an exact dollar amount, then you don't have to put the cents. You could put 0.00, but you don't have to. Okay, now we're going to do a little bit of algebra here. What if we know the simple interest is $63,000 on a $200,000 loan or investment, and the rate's 3.5%? How many years would it take for that interest to happen? So basically you're plugging in the I, the P, and the R, and you're solving for T. Yes, T is the one we don't know. So you always have to have 3 of the 4 given to you. And usually they give you the 3 that are after the equal sign. Usually they give you P, R, and T. But any of these 4 things could be an unknown. So in number 3, the interest is $63,000. The principal or present value is $200,000. The interest rate was 3.5%. So you move it over twice and you get 0.035. And then we don't know T. T is what we're looking for. So usually you just multiply all 3 of these things together and you get the answer. Well, this is kind of a working backwards problem. So because of the variable T, I can't do the whole right side of the equation. But we can do these 2 multiplied together. So if I take 200,000 times 0.035, the only difference now is I'm stopping at that point. I'm not multiplying by T because I don't know what it is. But I can write 7,000 T, literally, like a variable in algebra. And if these big numbers bother you, think of in algebra like if you have 10 equals 2x, just make the numbers smaller. This is like 10 equals 2x in algebra, where I have smaller numbers to deal with. The goal is to get x by itself, or in this case, t by itself. And when you do 2 times x, the opposite of multiplying by 2 is dividing by 2. And then that's why the 2's cancel out, and you get x equals 5. Many students can understand it when the numbers are smaller, so if it helps to think of a smaller example, you just divide by the number that's in front of the variable. So divide by 7,000. And you can certainly type this in a calculator, but the zeros cancel out 1 by 1. And 63 divided by 7 is 9. So this will take 9 years for this to happen. But I could type 63,000 divided by 7,000. And that's 9. Whoops, this tipped over. So t equals 9. 9 years. And the next couple of problems might make the interest rate or the principal the unknown as well. They do that sometimes too. Well, here's another one for time. So this is exactly the same problem, just different numbers. Same deal, I equals PRT. We know the interest is 84 bucks, not very much because maybe the time is low or the interest rate is small. The principal amount and the principal's small too, so $800. The last one was $200,000. Now somebody's only borrowing or investing $800. The interest rate's 2.1%, so move that over twice and make it 0.021 times t. So all you can do is this part first. 800 times 0.021 is 16.8. So that goes in front of the t. And then you just always divide by whatever's in front of t. Divide by 16.8. 84 divided by 16.8, and usually these come out exactly, but maybe not. This one came out to exactly 5 years. So that's hardly worth it if you put $800 in the bank and come back 5 years later and all they do is give you 84 extra dollars besides your money back. But that's because the principal's low, the interest rate's low, and simple interest doesn't grow as fast as compound interest does. Okay, see, I said this was going to happen. Now the interest rate is the unknown. Any of these four can be the unknown. Usually the principal is the unknown, but any of the four can be the unknown. So 5, we just have a different unknown. Now we don't know the interest rate R. So we have to know T, we have to know P, and then we have to know I. I is 248, simple interest 248. The principal amount is $500. And the time is 8 years. So even though they're not right next to each other, you can still multiply these two together because this is all multiplied together. And 2 times 3 times 4 is the same as 4 times 3 times 2, or 4 times 2 times 3. You can do it, if it's all multiplying, you can do it in any order you want. And I can't do anything with the R, so that's just going to be at the end. But 500 times 8, whoops, is 4,000. So you're getting 4,000 times R equals 248. Always divide by whatever's in front of the variable. Divide by 4,000. Now remember how I said that they always quote R as a percent, but then you work in decimals in the calculations. So this will end up being a decimal because I'm doing a calculation right now. And also if you're doing a division problem in a fraction, if the top is smaller than the bottom, the answer is less than 1. It's a decimal. 248 divided by 4,000 is 0.062. So now we're going the other way. This is why we practiced this back in section 7.1. Now I need to move the decimal 2 this way so that it's 6.2%, because they're going to want a percent answer, I'm almost sure. So remember, the percents look bigger than decimals. The decimal's 0.06, but the percent is 6.2. 6 is bigger than 0.06. Would you rather have $6 or 6 cents? $6 is more. Round to the nearest tenth of a percent, although it came out to exactly a tenth of a percent, so I don't need to do any rounding. But if the decimal had been longer, then I would have stopped after the first decimal. So usually the principal is the usually the interest is unknown, and we have these 3 given to us. But we've had 2 where time was unknown, 1 where rate's unknown, maybe there'll even be 1 where the principal's unknown. Yep, here it is right here, principal's unknown. So the interest is $247.80. The interest is $247.80. We don't know the principal or present amount. There should be a rate as a percentage and then change it to a decimal. 14%. Remember, when there's no decimal, it's in the back, so move it over twice and you'll get 0.14. 0.14 for the rate. And then hopefully the time is in years, which they've all been so far, but we might see one coming up soon where it's not in years, and then I'll show you what to do if that happens. So this one's luckily in years, 3 years. Once again, even though we haven't done this version of the problem, there's all multiplication on the right side of the equation. So you can just multiply the 2 that have numbers. 0.14 times 3 is 0.42. And p times 0.42 is the same thing as 0.42p. You see, you had like p times 3 times 4. 3 times 4 is 12. P12, but they always write 12p. Nobody ever writes P12. So whenever there's a variable, no matter where it is, front, middle, or back, after you've done the math part, just put it in the back. The variable always goes in the back when you're done working with something. So now divide by whatever's in front of p. So 247.80 divided by 42 cents. 247.80 divided by 0.42 is exactly 590. So that was the principal or present amount. Somebody put $590 in a bank account or borrowed it or invested it. And then 3 years later, it got them $247.80 of interest. So you always get your money back plus then the interest if you're the investor. So 500 and what did I say? 590. Here's an, okay, no. I thought maybe they were going to switch the years to something else, but this is like the first two problems. I know why they're doing this problem though. This is exactly like the first two problems where we know the principal, the rate, and the time. We're looking for the interest. That's the more normal way of doing it too. The reason they're doing this is the time is a weird 1.5 years. So 7 is like 1 and 2 where they give you the three things you need basically. P, R, T are all given to you. And you're trying to calculate the interest. So 48.50 is the dollar amount. The interest rate is 7.01, so move the decimal 2 to the left and make it 0.0701. 0.0701. And the 1.5, a couple of things about that again. I think we did one of these last time. 1.5, if you want to make it an improper fraction, you multiply downward. 1 times 2 is 2. And then you add upward. 2 plus 1 is 3. And then you just put it over 2. It's 3 divided by 2 is the same thing as 1.5. And 3 divided by 2 is exactly 1.5. And literally 1 and 1/2, whenever you have a mixed fraction, it's literally a plus between it, even though they never write it that way. 1 and 1/2 literally means 1 plus a half. And if you know a half is 0.5 as a decimal, like a lot of people do, that's also why this is 1.5. And it has to be in years, but it can be a decimal. That's okay. It's okay to have a decimal here. So time isn't the amount of time you put money in a bank. It isn't always exactly a year later where maybe you need to get the money out of the bank. So maybe 1.5 years from now, you need the money for something. It's not that they're going to force you to wait 2 full years to get your money if you don't take it out after the first year. So 48.50 times 0.0701 times 1.5. And now see how this answer is a big long decimal or longer decimal? So we would never write this whole answer. If you write the whole answer, it's wrong. Either you want to round to the dollar, which since there's a 9 one place after that, you would have to add 1 to this 9 and think of it becoming a 10, make 510. If they want dollars, this is $510. If they want cents, then you look at this third digit, that's a 7, and that adds 1 to this 7 and turns it into an 8. So 509.98, that's the cents, 509.98. And it's always only one of these two. You never put anything else. You would never put 1 decimal, 3 or 4 or even more than that. So it's always either 510 or 509.98. And they do want nearest cent right there, nearest cent. So 509.98. Okay. Okay, now I know what's happening. Okay, I thought this was exactly what we've been doing lately, but I thought this was exactly the same as problem 1, 2, and 7 because they're giving me P, R, and T again. But this is the other half of the formula sheet. Remember I said there were 2 formulas for simple interest, and this one says find the future value of the loan. Find the future value of the loan. See, you can just calculate simple interest. That's what the first 7 problems we're working with. Or you can get the future value with simple interest. And this, what this is amounting to is how much money you walk away with if you're the investor. if you invest $1,000, just for example, you're guaranteed to get your money back if this is like in a bank or something like that. If you put money in a savings account, your money's guaranteed. You can't lose it no matter what. Even if the bank gets robbed or burns to the ground or goes out of business, the government guarantees your money. So if you put $1,000 in there, you get to take that money whenever you close your account or whenever you want your money. But you get interest for leaving your money there. So you're getting a profit for leaving your money in the bank. And that's what future value is if you come back in a year or 2 years or a year and a half or 10 years, you get your $1,000 plus you get the interest. And that's what this future value does, is it takes the original amount P and it adds the interest. So it's basically one extra step compared to the first 7 problems. So now future value, I don't know why they use the letter A for future value when there's no A in any of those 2 words. Future, I guess value has an A, but present value does too, and present value is a P. I guess F was used for something else, or maybe they want to associate it with the letter F. But future value A is the present value plus PRT, which is really the interest. So you're basically doing what you did on 1 through 7, and then you just have an extra step of adding the original amount back in. So let's take this from the investor's point of view. Somebody's going to somebody's going to invest $1,000. Although if they borrow $1,000, it's the same idea. So let's say it's investing though. Say somebody puts $1,000 in a savings account at the bank. And then you write the 1,000 again. The P's there twice. Then find your interest rate, but change it to a decimal. 7% is 0.07. And they're still doing years. I'm assuming they're going to do something other than years soon, but maybe not. 4 years. So you can multiply all this together because there's no variable there. And that's what the first 2 problems were like in the beginning of this homework. The first 2 problems and even number 7 were like that. So 1,000 times 0.07 times 4 years. This person, if they're the investor, they're making $280 of profit. The first 7 problems only wanted to know what that answer was. They just how much interest is involved. But now it's future value. So say I want to close my account in 4 years. Maybe you're just starting off college and you want to save up for a down payment on a big screen TV or a new computer or a new phone or maybe even a used car. And you put some money in the bank now when you're starting college and so I'm just going to save this money instead of blowing it while I'm in college. And then when I get out of college in 4 years, now you got free money and you still have your $1,000 too. So now you have $1,280 to work with. If you would have kept the money in your house under your pillow, it would only be worth $1,000, and that's assuming it would still be there in 4 years. Maybe you would have spent it, or somebody would have stole it, or the house burned down and you lost it, or somebody broke in and robbed you, or so it got thrown in the laundry accidentally and got ruined in the wash. So there's not only safer in the bank, but you get profit in the bank. Or if you leave it at home, you might have something happen to it and you don't get any profit for leaving it at home. And you might spend it if it's sitting around anyway. So $1,280, this is a good deal. You just got $280 free dollars for no reason. You don't have to do any work for it, I mean. Okay, future value, same thing. Just an second example of this. So number 9, same thing. Somebody's going to put $700 in a bank account, or maybe you're borrowing $700. Say you're the borrower this time, and you need to borrow $700 to get a new phone or something. And then you write the 700 again. 8% interest rate, so 0.08. And then you're going to use the money for 9 years and pay them. Well, it's not a good example for a phone, but so maybe it's like getting a car or something, but this is just a made-up example anyway. But the years happen to be 9 years. Okay, so you can always do everything up to the plus. If you start mixing multiplication with addition or subtraction, then you got to slow down But if you find a part where it's all multiplying and dividing, and here there is no dividing, but if it's all multiplying and or dividing, then you can do it all at once in a calculator. So 700 times 0.08 times 9. You can do all that together. 504. So say you had like a rich uncle or something, or a parent that gave you $700 and they said, just pay me back 9 years from now. That seems kind of weird that they'd wait 9 years, but 9 years from now, you would need to pay them $1,204 because, whoops, you would be giving them their $700 back, and you'd be giving them $500 for their interest. 700 plus 504. And people borrow money all the time. Somebody just needs the money, so they're willing to pay more later to have the money now. So give me the 700 now, and I'll give you 1204 9 years from now. That's what's happening if you're the borrower. If you're the investor, you're kind of like losing the $700 now, but 9 years from now you get $1,200, so then you made a profit at least. Now, when you borrow from like a friend or a relative, then sometimes they don't pay you back, and that's bad. But if you do this in a bank, then the money's guaranteed 9 years from now. Okay, same thing, except they're doing 3.5 this time. So 3.5, if you want to do this here, you can go 3 plus a half, literally 3 plus a half. The time is 3.5 years. So do the 940 for the principal amount. Move this decimal over twice and make it 0332. And then multiply by 3.5 for the years. There's the interest. The interest is $109.23. That's just the interest though. So now add the 940 that you borrowed or invested to begin with, and now your account, if you're the investor, your account's all the way over $1,000 now. 1,049, and if they want cents, put 23. 3. Make this 2 become a 3 because there's an 8 after it. Nearest cent, yes. 1049.23. 1049.23. Okay, now they start doing, this is basically something we've already done probably. I haven't even read it yet. But the idea here is, here's an actual scenario. And can you still do the problem when it's in a scenario format and you have to decide what goes where instead of it being kind of spoon-fed to you? So in addition to working and a family contribution, Jane had to borrow $5,500 over the course of 6 years to complete her degree. The interest is $27.85 Find the rate. Round to 2 decimal places if necessary. See, it wants me to find the rate. And we know how much she borrowed. That's the present value. And we know the interest. And we know the time. So this is back to the one where we solved for the R. Where was that one? I guess it's further back. Maybe I didn't write that one down. Oh, here it is. Okay. See, it took me a while to find it for some reason. Remember when we were solving for R? This is the same problem. It said, what is the rate? So it could come from the future value, but there would have to be $2 amounts for that. There is $2 amounts, but there would be 2 larger dollar amounts. This is the 5,500, and this is 2,000. Well, there are $2 amounts here, but this one's clearly labeled interest. So that's why you'd want to work with the one where the interest is in there. This one doesn't have interest directly, really. And it doesn't, and really the problem's not telling you the future value either. So I am going back, even though we did this in 1 through 7, I'm going back to the first formula, interest equals PRT. Because we know the interest. They said the interest is 27.8520. 27.8520. And then there's only $1 amount other than that, so 5,500 must be the present value. And that makes sense because when people borrow for a loan, they get the money right away. They don't have to like wait 6 years in the future. Who would take out a loan and say, I'll wait 6 years for you to give me the money? That doesn't serve any purpose. So R is the one we're looking for. There can only be one unknown in a problem. And then the time is 6 years. See, if you tried to use the future value formula, you would have two unknowns. You wouldn't know the future value and you wouldn't know the R, so that's never going to work. So here, these can be a little more challenging because some students don't know which formula to work with when it's in like a sentence or a paragraph format, and it's not like completely labeling everything for them. So 5,500 times 6, that's about all I can do on that side. 33,000 times R, always put the variable in the back, and then divide by 33,000 because that's the one that's in front of the variable. And anytime you're solving for the interest rate, the bottom of the fraction should be bigger anyway because you're going to get a decimal amount that will then turn into a percent. So 2785.20 divided by 33,000. 0.0844, and we're going from a decimal to a percent, so the percent should look bigger. Move this decimal over twice and it'll turn into 8.44%. And they said 2 decimals and I've already got 2, so there's no rounding involved. It's exactly 8.44. To take advantage of a going out of business sale, the college corner furniture store had to borrow some money. They had to pay back a total of. See, that's the future value right there. They're paying back a total of. That's future value. And here's the first time it says 9 months. It's not in the years. And the rate's 6%. Find the principal, round to the nearest cent. So we're looking for P, and we don't know interest at all here. So this is why we have to go to the other formula. A equals P plus PRT. And we're looking for P. It literally says find the principal. That's obvious. It's good to know what's the one unknown here. The one unknown is going to be an A or a P or an I or an R or a T. It's got to be one of those 5. And here there's 2 P's, so I just write it twice because I don't know P. The dollar amount of 160,000, that's the future value. This is what they're going to have to pay back in the future. And then it's a 6% interest rate, and it's 9 months. So 0.06. Now here's what happens if you don't get years. Normally you just multiply by the years. So go ahead and multiply by the months, 9 months. If it's in years, you just literally multiply by whatever it is. When it's in anything besides years, like months or days or weeks, or they even do quarters sometimes, then you have to one extra step of dividing by how many of these there are in a year, whatever the units are. How many months are in a year? 12. So I have to have an extra step of dividing by 12. Whoops. If there's days, then you divide by 365. Weeks, divide by 52. Quarters, divide by 4. It's just one little extra step. So normally you would have just multiplied these two together if there had been years given to you. Well, you can do all this together too. See how there's no addition or subtraction of what I just circled? Anytime there's no addition or subtraction in a part where there's multiple things to do, you can do it all together if there's no addition or subtraction there. So I'm going to type 0.06 times 9 divided by 12, literally. 0.06 times 9 divided by 12. And it came out to exactly 0.45. Now, the trick to finishing this is there's some algebra here. Remember in algebra when you do 2x plus 3x, or maybe you don't remember this, but 2x plus 3x in algebra equals 5x. When you're adding variables, you don't do anything to the variable, you just add the 2 and the 3. And the trick to it is the x has to be the same. If one was an x and the other was a y or an x squared, then they don't add together. But if they're both x, they add together, and you literally just add the numbers. That's literally what's happening here. P is literally 1p. And remember what I said with p times a number, you can put the number in the front and the p in the back. I think we had like p times, I don't remember now, p times 7 or something like that, and it was 7p. So if you rewrite both of those like that, then maybe you'll recognize this better, that it's literally 1 plus 0.045, which is easy. It's 1.045. Anytime you add 1 to a decimal, it's 1 point whatever it is. And then you just divide everything by the number in front of the variable, as always. Now here's another little rule, maybe it helps to know. Future value is always bigger than present value, otherwise nobody would invest. And they gave me the future value of 160,000. So they would never go to a bank and say, we'll pay you back 160,000 if you give us 180,000 now. Who would do that? Who would give you more money now and get less money later? So they're going to get less money. They're willing to take less money now and pay more money later in order to get the money now. So this P better be less than 160,000, or we definitely did something wrong. If you know that little rule, it can help if you have like a slight typo, or maybe you put a number in the wrong variable. Some students are just oblivious to this, and they just type something in a calculator and it's completely wrong, and they're not even paying attention if it's even a reasonable answer or not. So I know this has to be less than 160,000 or something's wrong. See, it is less. It's 153,000. So basically, they're getting about 150,000 now, and they're willing to pay back 160,000 later because they need the money right now. And now we want to see, what do they round it to? Round to the nearest cent. So 153,110, 153,110 point. I need 2 decimals for cent. And there's an 04 for the first 2, but there's a 7 after that, so add 1 to the 4 and make it 05. Marco Rivera had savings of $849 invested at 6% for 5 years. Find the interest. Find the interest. See, that's clearly which formula to use too. Not only is that the unknown, but it tells me to use the interest formula. And we don't know the interest, so we better know the other 3 things. So there's only $1 amount, that must be the P, and that makes sense that if you go into a bank and say, I want to open a savings account, you have to hand them some money to do that. So Marco's giving them $849 right now in the present time to put into an account. And the bank's offering him 6%, 0.06 for 5 years. So he'll leave his money there for 5 years, come back in 5 years, and this is how much free money he's going to get then. 849 times 0.06 times 5. He'll get $254.70 on top of his money back. And you can take the interest and spend it on something and keep the money in the bank and let it keep making more money. So it doesn't matter if you take your original money out or keep it in there and let it keep going for a while. But they just want to know how much interest was involved. It's 254.7, but never write it that way. Never write 1 decimal. That's not money right there. So put a 0. You can always add zeros to the end of decimals. It doesn't change it. So if I'm going to do nearest cent, it better be 254.70. If you want nearest dollar, then 255. But it's one or the other only. Never put 1 decimal, never put 3 decimals. Only put 0 decimals or 2. Every answer should be 0 or 2 no matter what, as soon as it's about money. 254.70. It doesn't say what to round to, so I guess they would take maybe 255, but let's try this. Okay, when Cecilia's car needs a new transmission, She's stuck with a bill of $1,749. The dealership offers her an 18-month loan at 14.7% interest to be repaid in 18 equal installments. See, 18-month loan and 18 installments, that means she's going to pay once every month. Find the monthly payment. Round your immediate steps to the nearest cent. Okay, so there's a dollar amount here it's the present value because this is what she owes right now. She has a present value, a loan of $1,749. There's an interest rate and there's time involved. So we could figure out the future value, and then if we then figure that out to the month, we can know how much her monthly payments are. So there's only two formulas to pick from right now. It's either interest or future value, and I'm thinking future value works better because there's nothing here about interest in this problem. But if she has this bill to pay, that she could pay it right now if she had the money, but she doesn't. So by taking a loan, she's going to end up paying more in the future than she's getting for right now. So to me, it makes more sense that we'd be using the future value formula. And let's calculate the future value first. So future value is present value plus PRT for the interest. So unfortunately, she doesn't have $1,749 right now. So she's going to owe interest on it in order to get the money now. The interest rate, and they do this when you're desperate too, they make the interest rate real high. So 147. It's like a loan shark almost. Now, 18 months. She's got to pay this money back in 18 months. So that's where you have to divide by 12 months because there's 12 months in a year. So do everything up to the plus sign, or I should say everything after the plus sign first. So 1749 times 0.147 times 18 divided by 12. You can do all that together. So there's $385.65 of interest is what she's having to pay eventually because she needs the money right now. $385.65 if I do it dollars and cents. $385.65. So now add the $1749 that they're paying her right now. So she's going to end up paying, in the end, if she could pay it all at the end, it would be $2,134.65. Now, usually when you get a loan, they don't say, okay, I'll see you in 18 months, give me all the money in 18 months. If you don't have all the money now, how are you going to have all the money then? So they're only willing to do this if you make monthly payments, and that way if you can't pay in any given month, then they can come like take your car or take your house or whatever. But if you could go all 18 months and then pay after that, this is how much you'd pay. So if we divide this by 18, then that'll be how much you're paying every month. And this is kind of good. You go on a payment plan where it's an affordable amount. Most people can come up with $100 every month as opposed to $2,000 all at once. So if you can pay $118.59 every month, then you'll pay this $2,000 loan off eventually. And notice the next digit's a 1, so don't add anything to the 59. $118.59. Okay, so you can't see it, but all the problems are green right now. We're done with section 7.3. 7.3 was simple interest. Get this to stay. Okay. Let's close that one. 7.3 simple interest. So compound interest is similar. Come here to the formula sheet. We're now going to be using this third formula. they don't do interest for, there's no formula for the interest in compound interest. You just do the future value. And then you can figure out the interest after that, actually, with one calculation. So there's no formula for compound interest. It's just future value only. And there's two differences compared to this simple interest future value problem. Here you're taking the initial amount that's borrowed or invested, and it's right here too. Here you add the interest, but in this one you multiply. And normally when you multiply things in math, they get bigger. And then instead of multiplying by the r and the r and the t end up getting exponents. So that's why compound interest will grow faster than simple interest does. And this came about when calculators and computers were coming into play. While I'm opening up 7.4, let's do another magic word of this unit 3. This unit should have 5 videos, so this will be the second of the 5. And if you remember what the first one was, it's the same theme. This time we're going to go with Venus, the planet Venus. Send that to me as soon as you have a chance to. So describe the difference between simple interest and compound interest. Simple is all about adding the interest, and compound is all about multiplying it. So simple interest is computed only on the principal amount, because it happens you just do that one time. Compound interest is computed on the principal and any previously earned interest. So that's another reason it grows more. Simple interest, all they use is the initial amount to calculate the interest. But in compound interest, every month or every quarter or every year, there's new interest on top of the old interest. So that's what helps it to grow faster. What does it mean to say that interest is compounded monthly? Compounded monthly means the interest is compounded 12 times a year because there's 12 months in a year. So that's what compounded monthly means. You're going to do it 12 times a year. Okay, so here's how this works. We're using the third formula now. So this one right here. And you'll know because it says compounded something, like compounded annually, compounded semi-annually, compounded daily, compounded monthly. So A equals P times 1 plus R over N to the NT power. You're going to get used to this formula because it's used a lot. This is number 3 of the section 7.4. A equals P times 1 plus R over N to the NT power. So the principal or present value is $815. Somebody's borrowing or investing $815. There's always a 1 here. The interest rate is 5%, so make that 0.05. Now, the N stands for how many times per year you're doing it, exactly like that previous question. N is the compound times per year. So monthly is 12, daily is 365, quarterly is 4, semi-annually is 2, but this one's annually. Annually is once a year. So then you put a 1 here and a 1 there. It always repeats. And then the years, usually they give you years here, so 8 years. So there's really 4 steps to do. 2 of them in this case are very easy. I do the exponent first step. Eight times 1 is 8. Hopefully that's easy. If it's not, use a calculator. Second step, do the fraction. This sometimes is hard, but this time it's really easy because anything divided by 1 is the anything, 0.05. Now, I'm writing this a little slower than you're going to see me do on all remaining problems. So really this one's got 5 steps because I'm doing one little extra step here. Every single time you're going to have a 1 plus a decimal in this parenthesis every time. And literally 1 plus a decimal is 1 point whatever the decimal is. So I'm not going to write this twice from now on. I'm just going to instantly go to 1.05 or whatever it comes out to. So I'm not even going to count that as step 3 yet. Step 3 is doing the exponent next, because in order of operations, exponents come before multiplying does. So step 3 is the 105 to the 8th power. This is why it's good to have a calculator that has an exponent button. 1.05 raised to the 8th power. Otherwise, you have to type 1.05 times 1.05 times 1.05 8 different times. So you physically could do it, but it gets painful after a while. Now, another issue is you don't want to round this decimal. It's okay on your scratch paper if you're just rounding it for yourself so you see your work. See, I'm just going to write 1.477 dot dot dot, but I'm not going to round it here. The last step is to multiply and just hit times while this is still on the screen, so you get the whole decimal times the dollar amount in front, 815. That's always the last step. So this is step 4 to multiply, but don't round the decimal. Here's the final answer. Whoops, wrong screen. This is what I'm looking for. $1,204 or $1,204.13 if they want cents. 1204.13, yes, nearest cent. So that's how you get future value. It's a 4-step process now instead of a 2-step process. Then there's no formula for the interest because the interest is found by simply taking the future value, and if you subtract the original dollar amount, that's the interest. So take this 1204.13 that we just got for an answer, instantly subtract the principal or present value that was the original dollar amount. So you get your $800 back and you get another $389.13 in free money. So this is the gist of compound interest, but this one was annually. I'll bet they're going to do semi-annually and quarterly and monthly and daily. See, semi-annually next. Same problem except semi-annually. So $1,405 is the initial investment or loan amount. The interest rate is 0.8%, 0.8%, so you have to move the decimal over twice. So that's really 0.08, not 0.08, but 0.08. Watch out for something like that. Semi-annually means you put a 2 in the denominator and a 2 in the exponent. Those two numbers always repeat. And then the time is 12 years. I'm going to do step 1 and step 2 at the same time. Hopefully you can get used to that. $1,405, and it's going to be 1 point, whatever that decimal is. 2 times 12. If that's hard to do, do it in a calculator, but probably you know 2 times 12 is 24. And same thing with the fraction. If you can do that in your head, fine, but 0.008 divided by 2 is actually 0.04. So maybe you could do that in your head too, but 0.04. And then it's automatically 1.004. Rather than adding that extra step of +1, it's just going to be 1 point whatever. So now step 3 is always the exponent. $1.004 to the 24th power. And I'll just write 1.1005 dot 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 because it goes on for a very long time. But just instantly hit times the dollar amount of 1405. So here's the future value answer. 1546 and 27 cents. 1546.27. and then subtract the 1405. The initial dollar amount, if you subtract 1405, that's your interest. So here you're getting $141.27 of free money. Okay, daily. The only difference here, it's daily. So somebody's borrowing or investing $790. The interest rate is 7%, 0.07. Daily, you do 365 for both the denominator and the first slot of the exponent. And they're only doing this for 1 year, so times 1. Okay, so 365 times 1 is clearly 365. That's easy for step 1. Unfortunately, 0.07 divided by 365 is going to be a really messy decimal. But as soon as I add 1 to it, it'll be 1 point whatever that is. 0.07 divided by 365 is some big... Whoops, I didn't type that right. Oh, yeah, I did. Okay. So just hit +1. See, it's 1.000191. Now raise it to the 365 and multiply by the 790. So now your 790s in 1 year has just grown to 847.28. Bump that 7 up to an 8. 847.28. Subtract 790, and that's how much interest you made. Not very much here. It's only $57.28. So we did yearly, annually, we did semi-annually. Now here's daily. There'll probably be a monthly and a quarterly coming soon, if not right next. Here's weekly. That's another one you can do is weekly, and this is for 38 years. That's an incredibly long time. Okay, so I'm going to do... The dollar amount goes first. And this is a large dollar amount too, 117000. The interest rate is 4.42, so move it over twice and get 0442. 0442. Weekly, there's 52 weeks in a year. And you're doing this for 38 years for some reason. So maybe this is like a retirement account and you're just going to save up till you retire in your 60s or 70s. So now the exponent is not very easy. 52 times 38, you'll need to do that in a calculator, but it's 1,976. Do the fraction next. 0442 divided by 52. And immediately add 1 to it. So that way you'll get 1 point, whatever it is. 1 point. Now that's weird how it came out nicely. 00085 exactly. It wasn't some really long decimal like the last couple of problems were. 2 steps left. Do the exponent third. And once you get that, multiply by the dollar amount. So raise this to the 1,976 power times the $117,000 initial investment. Whoops, too many zeros. This is going to be a ginormous interest here. This is $627,000, 627, 071, 46, and there's a 2 after that, so don't add anything, just leave it 46. And then subtract 117,000 to get the interest. The interest is like 5 times bigger than the initial investment. 510,071 and same 46 cents. Oops. 46. So you invested 100,000 and you ended up with 600,000 in the end, and 500,000 of that was free money. This is why retirement accounts are so nice if you start early enough in your working career. Okay, which is a better investment? Okay, 3.34 compounded semi-annually or 3.345 quarterly. Okay, so there's this thing called effective rate, where when you take the main formula in the effective rate, if you're just comparing rates to each other, we get rid of the dollar amount, because the dollar amount, whatever it is, it's going to affect it the same way. So the dollar amount doesn't matter. The T doesn't matter because they always do it based on exactly 1 year. So if I do 1 plus 3, make this 3.34 become 0.334. And that one is compounded semi-annually, so then put the 2 twice. And just do this much here. So you just have to do the fraction, 0.334 divided by 2. Add 1 to it, so that it's 1 point whatever it is. Raise it to the second power, because there is no t. And then you, yeah, that's it. There's nothing to multiply in front by. But then we want to get rid of the front one, so if you minus 1, that gets rid of the front one. So this is what's called the effective rate, 0.337, let's say. 0.337, or what would be 3.37%. See how it's a little bit higher than this 34? The 34 turned into a 37 by doing that. There was actually a law passed by Congress. Car companies used to get away with this a lot when they sold cars. They would put 3.34 on the sticker of the car, but you were actually paying 3.37 in the long run. And it was kind of true. There was no truth in advertising, so they passed a law. They're not allowed to do that anymore. They have to tell you it's actually 3.37 and not 3.34. Because when you do 3.34 semi-annually, that's the same as 3.37 annually. So do the same thing for the other one. This one's 3.45, but quarterly. So 1 plus 0.345 quarterly is 4 times a year. So do the 0.345 divided by 4. Add the 1 to it. Raise it to the 4th power. And then get rid of the front one by minusing 1. 0.349. 0.349. And then move this over twice, 3.49. So the second one's better. The quarterly is better because it has a higher effective rate. When things are on different scales, if you compare them to just once a year, then you can see which one's better. Okay, a couple decides to set aside $3,500 in a savings account for a second honeymoon trip. It's compounded quarterly for 11 years, 7%. How much will they have in 11 years? So in other words, what's their future value? This is just interpreting a word problem where you're just doing the future value formula that this section's about. It's the same as the first couple of problems, like 3 through 6, except you have to decide which formula you're using. How much will they have in 11 years? That's a future value. So they're putting $3,500 in a savings account right now. This is, you always put money in a bank right now. That's definitely the present value. They're getting a 7%, 11 years. And the quarterly, compounded quarterly. So then you put a 4 here and a 4 up there. This is back to the 4 steps. So do the exponent first. 4 times 11 is 44. Do the fraction second. 0.07 divided by 4 is 0.0175. So then you're literally going to get 1.0175. So once you have the decimal version of it, add 1 to it, so it's 1.0175. Raise it to the exponent of 44, 2.145. And then don't round it here and multiply by the 3,500 that they invested. See, this is a very good deal for this couple. They just got married. They went on their first honeymoon, and then 11 years from now, they want to have like a, it's weird, this 11 years, usually do like 10 years or 20 years, but on one of their big anniversaries, maybe they've already been married for a few years, maybe they've been married for 9 years, and they want to do this when they're at their 20th anniversary. All they have to do is put 3,500 in the bank, and they get 7,500 11 years from now, 7,509. Nearest cents, I'm going to put the double zero because, well, actually it should be a 1 penny because there's a 5 after the second zero. But if it is double zero, you normally don't have to put that, but there is a 1 penny there. See how good that is? Their 3,500 grows to 75, or they're going to get $4,000 of free money. They're more than doubling their money by doing this. It's a very good idea if you can afford these kind of things and save up for a big thing like a honeymoon or a car or a house or a retirement account. That's where this financial chapter is so helpful. A 35-year-old plans to retire at age 50. See, they know that they're 35 now. They want to retire 15 years from now. She's going to invest in a inheritance of $75,000 at 7% compounded semi-annually. How much will she have at age 50? So that means how much in the future will she have when she's 15 years from now? This is the exact same kind of problem, just a different scenario. So she has $75,000 she got in inheritance. Many people, when they get an inheritance, they just blow through the money right away. And then they're right back to where they were when they started. She's going to invest it for 7% compounded semi-annually. 0.07 semi-annually is twice a year. And she's doing it for 15 years because that's the difference between age 35 to age 50 is a 15-year span. Same 4 steps as usual. Do the exponent first. 2 times 15 is 30. Do the the fraction second. Turns out 0.7 divided by 2 is 0.35 exactly. So then you're going to get 1.035. But then add the 1, so it's 1.035. Just always add that 1, and it's always 1 point whatever it was. I kind of do those 2 steps together. And then by order of operations, you would do the exponent before you would multiply. So now raise it to the 30th power. And then multiply by the 75,000. See, she got 75,000 inheritance, but then 15 years from now, she could retire with over $200,000 and more than double or almost triple her money. 210,509. 210,509 point. They're doing near cent every time. 52 cents, but there's a 7 after that, so make it 53 cents. To pay for new machinery in 5 years, see, in 5 years, that's future value. A company owner invests $10,000 right now, obviously. Right now, they're going to invest $10,000 so they can pay for this in 5 years. 9.5% compounded quarterly. How much will be available in 5 years? Future value again, same exact formula. So they're investing $10,000 right now. 9.5% is 0.95. think it said quarterly. Yep, compounded quarterly for 5 years. So put the 4 for quarterly here, 4 for quarterly there, and then times 5 years. The exponent is clearly 20. .095 divided by 4. Whoops. 0.95 divided by 4. 0.2375. Don't round anything. 0.2375. Add the 1 in front. Raise it to the 20th power. And multiply by the 10,000 in front. So they're going to invest 10,000 now, and now they've got almost 16,000 in 4 years, 5 years from now. And they want nearest cent as usual, so 15,991.09, but there's an 8 after that, so 1 penny plus 9 pennies is 10 pennies. If you're adding 1 to 09, it turns into a 10. After the birth of their first child, the Bartons plan to set up an account to pay for her college education. A lot of people do this, parents or grandparents. The goal is to save $30,000 over the next 15 years. And their financial planner suggests a bond fund that historically pays 6.4% compounded monthly. How much should they put in the fund now? See, there's the question. How much should they put there now? What should the present value be? They know they want to give this child $30,000 15 years from now, right before they go to college. And how much do they need now? It turns out you don't need $30,000 now to have $30,000 later. This is where it's a good deal. They're going to pay a lot less than $30,000, and this kid's going to get the $30,000. So the other option is just wait 15 years and try to give them $30,000 then. But then you're paying all of it. By doing this, the bank's paying a lot of it from interest. So this is a working backwards problem. Basically, the two things right here are reversing order. I know the future value, and I'm going to put that in 30,000, but I don't know the present amount, so that's the unknown this time. And it's 6.4% compounded monthly, 0.64. Monthly is 12 for the denominator and the front part of the exponent. And they're doing this for 15 years when the child, either they're 3 right now maybe, and they'll turn 18, or maybe they just want to give it to them when they're 15. Some students in high school are already taking college classes. So the exponent's not easy this time. 12 times 15 is 180. It turns out there's still 4 steps here, but the 4th step is the only thing that's different. So the exponent's 180. Do the fraction next. 0.64 divided by 12 is, unfortunately, a big messy decimal. 0.0533333. But keep the whole decimal on your calculator screen and add the 1. Raise it to the 180th power. Okay, so right here, I have 2.605 and so on. Those 3 steps are the same as the other 3 that I've been doing on the last handful of problems. Usually the 4th and final step is to multiply by whatever p is, but we don't know p. But just like those other problems in the previous section, when you have a number times of unknown, you can divide by the number to both sides. And that'll equal what the variable is. The only issue is you can't round this 2.6 number. Don't type 30,000 divided by 2.6. That won't be good enough. Some calculators have a 1 over button, 1 over x. Also, there's a memory storage. Some calculators have memory store. I'm going to do this both ways. I'm going to store this decimal in memory so I have the whole thing. But I'm actually going to do another thing you can do is I would like to do 30,000 divided by this, but what if I have this divided by 30,000? That's backwards in the way it's supposed to be, so this is going to be the wrong answer. But if you hit the 1 over x button, it turns it into the right answer. So see if your calculator has a 1 over x in addition to the exponent button. If you have that, that's very helpful. See, it only takes $11,516 and 13 cents. These parents only have to invest $11,500, and then the child gets $30,000. They're getting almost triple their money. Now, what if you don't have a 1 over x button? Then you have to store the number in memory and or write the whole thing down, and then type 30,000 divided by memory recall. See, there's that 2.6 number in its entirety. And see, same answer that way, 11,516 and 13 cents. Okay, so let's see what's left here. Continuously. Okay, future value. I'm looking if there's any real short ones here. Monthly payments. Okay. So here's what's going to happen. I thought maybe they'd have some short answer questions like the first two, but they don't. I've done the first 11, and I've got 8 more to go, and this video is starting to get quite long. But one good news is there's only 3 sections left and 2 videos to cover that. So I'm not sure how long these are either, but I'm going to stop this video now just so this is like a normal in-person classes go for about 1 hour and 20 minutes anyway. So I'm going to pick up where I left off in the third video. The third video will be the end of 7.4 and definitely all of 7.5. And then I can do 7.6 and 7.7 in a video. Since there's only 7 sections anyway, that kind of works nice. Originally what I was planning on doing was 7.3 and 7.4 together, then 7.5 and 7.6, but then the last video might have been really short and might have been like a half an hour or 45 minutes long only. So this will help since there's only 3 more sections to go. So this will be the end of video 2, and I've given you 2 magic words to do. Video 3 will be the rest of 7.4. I won't just skip it. I'll go and pick up right in the next video with the rest of 7.4. And then we'll also include 7.5 in that video. And then the 4th video will be these 2 sections together. And that's another week out before we do all that anyway. So that's it for video number 2 of the 3rd unit of the semester.